All right, so this is an example of a derivation that has to be proved using an indirect route. In other words, by assuming the opposite of what it is that we're trying to prove. This is actually illustrating a pretty important principle in logic, which is known as De Morgan's law, occasionally referred to as the crank rule. And De Morgan's law has a couple of different varieties. We're showing one of them here. We'll talk more about this rule later on in class. But we're trying to show that if not A and not B, then not A are B, okay? And I think you can see that there's no way to get directly from here to here. And it's not really obvious what it is that we would assume to let us do that, other than the opposite of what it is that we're trying to get. So we're trying to get not A or B. We're going to have to proceed by an indirect route and assume A or B and show that that gets us into a contradiction. And this proof is going to take a couple of twists and turns. It's not a very straightforward one at all. So the rule that we're trying to use eventually here from this assumption is negation introduction. Now, what's kind of odd about this proof is that the negation, the contradiction that we're going to get from this is exactly what it was that we were trying to prove in the first place, which might seem a little bit strange. Like, why are we making this assumption to get it? Why don't get it by contradiction? Or why don't we just go ahead and get this in the first place? The reason is that we need something to work with, right? And this doesn't give us enough to get this, so we need some kind of additional premise or assumption to work with. And this is going to be that assumption. Okay, so now we have this and we have that, and what we're going to do is we're going to go ahead and we're going to start nesting our subderivations. We're going to make more subderivations, and we're going to use the rule of disjunction elimination on this line. So we'll go ahead and start with A. And what we're trying to do is show that both A and B are going to lead to this. They're going to lead to not A or B. Okay, but in order to get this contradiction inside of this subderivation, we need to go ahead and assume the opposite of, once again, assume the opposite of what it is that we're trying to get. So here A, we assumed A for purposes of disjunction elimination. Here we're assuming A or B for purposes of negation introduction. Okay, and so in a way our reasoning in here mirrors what we're trying to do in this larger subderivation. Now, we have a contradiction that we can get here in this subderivation. Okay, it's already there for us. We just need to reiterate A in. Sorry, my line numbers are getting a little bit larger than my lines are. So line 5 is A, and we're going to bring down this not A from line 1 to get a contradiction on lines 5, between lines 5 and 6. So line 5 is reiteration from line 3. And the reason the reiteration rule exists is just to get your contradictions together, to show the two things that contradict one another side by side. Okay. Line 6 is conjunction elimination on line 1. And now we're able to conclude on line 7 that not A or B by negation introduction, lines 5 and lines 4 through 6. Okay, so we're basically halfway there. A good idea at this point might be to pause this video and see if you can work through the rest of this on your own before I illustrate it, because it's basically going to be running through the same kind of reasoning exactly. But now we need to assume B, again for purposes of disjunction elimination. Again, we need to assume A or B for purposes of negation introduction. On lines 10 and 11, we're going to reiterate B into our subderivation. And on line 11, we are going to use conjunction elimination to get not B from line 1. And now we can introduce a negation. We know not A or B in this subderivation. Based on the subderivation on lines 9 through 11. Okay, so we showed that if A is the case, then not A or B follows. And if B is the case, then not A or B follows. Therefore, not A or B. Based on disjunction elimination, lines 2, the line of the original disjunction, lines 3 through 7, and lines 8 through 12. Now can we got not A or B, can we stop now? No, because it's still in this subderivation, right? Remember what we're trying to do here is negation introduction. So we have not A or B. We're going to reiterate A or B down to set it next to that and show our contradiction off. And that's reiteration from line 2. And now, based on this contradiction, we can go ahead and close off this subderivation and finish the proof. We have not A or B based on negation introduction, lines 2 through 14. So once again, that was kind of an involved proof. There was a lot of like kind of tricky little maneuvers there. It wasn't a straightforward one at all, but it shows that a lot of the time when there's nothing else that you can do, you need to get there by assuming the opposite of what it is that you're trying to prove. In fact, we did that 3 times in this proof.